Hi everyone, hope you all are doing well. I haven't made a YouTube clip for quite some time, but I've made I believe, a discovery in the last 2 or 3 weeks that I thought it's worth sharing with the world. So anyway, I've titled this video the 1530 RGB light spectrum colors in the rainbow or in a prism. So I've basically believe I found the formula to generate a rainbow. I've generated this by Cyan graphs, and I believe it is. I'll show you now that it's proof that it's pretty. I thought it was pretty amazing. But before I show you that, let's just quickly do a color test. They say here on the internet that the human eye can see about 1 million colors. So what I did is I generated a few colors. If you can see the individual lines here, then it means you can see about 1 million colors. So I've used the delta of 16. It means each color here, the red, got a RGB difference of 16. Where here I've kept the RGB the same for red, but I might have, you can see I think I've introduced yellow. So as I found out your eyes, this is just a test for you to do to see how many colors you can see. I struggle to see the difference here in the green for each line, and maybe the cyan here, but on general I can now confirm that average person should be able to see the distinction here. If you can see, like here, I can also see the difference in green, and you can see about 2 million, or here in red, you can see 2 million different colors. I can still see, so some of the colors our eyes can distinguish up to 4 million, but since we can't on average, I can't see distinction here, I can't see distinction really, but yes, here I can see it. So this is just the color test. So I was also asking the question, can a PC produce more colors than we can see? And the answer is yes, because if you use the RGB color system that I use to generate this, and all computers work on, they can generate about 16.7 million colors, which is much higher resolution. So I'm just saying this combination can produce more color, as I've proven here. So even here with a delta 4 million, as I say, the computer can generate more than you can see. So this is just a test for yourself if you are colorblind or not. And yeah, it was also interesting to see if women can see more colors than men in general, but I think it's more psychological thing. Okay, but let me continue. So yeah, it was very interesting to find this on the internet from Dr. Christopher Baird. And basically I believe he's given the best Prism breakdown of colors that I've seen. And so I just want to quickly read what he says. He says a prism splits white light into the fundamental spectral colors. Because the spectrum varies smoothly, there are an infinite number of fundamental colors. I was initially confused because I thought infinite will mean that you find all colors in the rainbow. So, but infinite, even the limited spectrum, as I will show you now, of the rainbow can be infinite, but our eyes just can't go. So the maximum code that I can show you is 1530 individual or RGB codes. Okay. So what I did next to prove that my formula, I believe, is very good, and that's why I like this guy's spectrum, was fantastic. I found other breakdowns, and it wasn't as clear as his. So I believe my generation of how I generated this color spectrum, I can now prove that I believe there's something to my formula. And as I said, I don't know if the scientific community has the formula, the sine waves, to generate a rainbow. And yeah, so let me continue. I'm quickly going to go here over basic colors. It might be of interest to you. Well, let's start with the pictures. I found this color called chartreuse, which is actually a French wine made by monks or something. It's a color that I didn't know existed, but just see, here it is. As you can see, it's definitely one of the prominent colors in the rainbow. It's half red and full green will give you this color. And then if you talk about your eyes, I've always said I've got brown eyes, but I believe someone pointed out lately that we got hazel, our eyes got hazel in it, so you can talk about hazel brown. The hazel brown, which doesn't look so nice when you just see it like that, or hazel green. Hazel green, there we are, is a greenish color. So I'm just showing you. So interesting. What I was trying to do here, I was trying to rearrange the colors according to the rainbow, and as I said, it wasn't such an easy task. But yeah, you got your reds and your orange and yellows, your green. I'm going to speak a little bit about, you know, the typical green that we imagine would be in a rainbow is this darker greens here. But the green, the true green that you get in rainbow, are actually much more closer to lime. And then you get your blues and your aquas and teals and colors that I've really never heard of. If you see the word XL in front of it, then it means it's part of this XL palette here at the top. So for interest's sake, sometimes the XL red and the true red are the same, but sometimes the internet, for instance, say the true orange is these codes, where your XL orange looks like that. So I just thought you will find this of interest. If you read through here, you might see colors that you've never seen before. And then, as I will show you later, there are a lot of these colors that are actually not in the rainbow. These funny codes combinations just doesn't exist. Maybe important one to point out is in indigo. I believe you won't find this color combination. It's not in my 1530 or RGB codes. So, but more on that a little bit later. Okay, so what I then tried to thought, my first attempt to build a rainbow, thought if you take a lot of colors, I added the totals of RGB and I sorted from small to big, and I thought maybe this will produce a rainbow, but no, all it does, it ranges colors from very dark to very bright. Okay. So next, so what happened is I saw this circle of RGB codes, and I used this, and I thought, what will happen if I use this as a starting point? I use the basic ones, like there's full red, there's full green. So and I basically produced this. I quickly want to go through this. So for me, on a level 1, or only 3 colors, red, green and blue, and as I show later, to get these magenta, it has to go back to red again. On your level 2, you would find yellow, so red and green gives you yellow, green and blue gives you cyan, and blue and red gives you magenta. Okay, so then so there's 6 colors in level 2. In level 3 is so if you start mixing red and yellow, you get orange. If you mix yellow and green, you get this yellow green, also called chartreuse. If you mix green and cyan, you get spring green. If you mix cyan and blue, you get aqua. If you mix blue and magenta, you get violet. And then, so here are the 12 colors of the rainbow. As I say, most of the top ones, everyone will agree, it's hard to show a rose on that color spectrum. Let me just switch my cell phone off here. Okay. Anyway, let's continue. So yes, then I thought I'll show you how the colors intertwine. So if you start here with the basics, the red and the green there, it will form a new color. Yellow, good, orange, yellow, and so what I want to point out, in level 1, when you go from level 1 to level 2, it generates new colors. Okay, and you need red in the middle to get this magenta. If you go here, it generates, as I say, from here to there. These two then generate your orange. So these are the basic ones. But what I also want to show, if you then go further from level 4 and onwards, you don't really generate new colors as such. So it's the same. It's the same as I've shown here. I went to a fourth of each colors, and then you will see it just interweaves into the others. Okay. So finally, if you go to the internet now and you go read, you ask what are the colors of the rainbow, it will tell you these, most of it will tell you there's 7 colors: red, orange, yellow, green, blue, indigo, and violet. Then if I went here to Wikipedia and read about the history, so Newton, okay, as I say, Newton might have looked at a spectrum. I don't know, that this was also with Wiki. It's very hard to see the detail here. That's why I was so interested about this guy's breakdown of the colors, because whatever technique he used, maybe lasers or whatever more modern techniques, it shows you much more clearer than maybe the spectrum that Newton saw. So Newton had a thing about the number 7. I have a thing about the number 8. So Newton then decided, well, there has to be 7 colors since there's 7 notes. Which, you know, but anyway, so he introduced then orange and indigo to get to 7 colors, and this is where the internet seems to have stuck. If you listen to the Rainbow song, or even I went to Edge and I asked the AI about the colors of the rainbow, and it gave me this line. So, but I'm glad they introduced this modern colors, where they introduced cyan. It's very clear, even in that spectrum, that cyan is there. And they've taken indigo out. As I said, it's not part of, I can't see it in my RGB codes, but blue and violet. Maybe just to point out that the green that they show here is, you know, it's why everyone thinks green is a darker. Green is actually this lighter green that are very close to lime. Okay, so I've went through the colors now. There are actually 12 rows fulls of the edge here. As I say, I can clearly show you the sort of 11 distinct colors, and here we're sort of losing the spectrum. But as I said, I would suggest very strongly that magenta gets added as a color of the rainbow. I don't know why it's not, because look. Okay, so there is blue, violet. You can see there between. You can definitely see there's a part of violet there, but magenta, according to this guy's spectrum, is very clear. I can see here that in this original spectrum that you can't see it so clearly. So yeah, I suggest these 8 basic colors of the rainbow, and that. Yeah, indigo should be taken away. So you've got blue, violet, and magenta at the end. Okay, so let me quickly show you. So what I've tried to here, these are the 1,530 colors. I made square blocks. So this is number 1, number 2, and I went and lined down this and this. I was just trying to show you as much colors as on one screen, and this didn't look as nice as the circles did. So let's go rather. Well, before I go to the circles, let me show you this way. So what I'm going to show you, I'm going to go down from the top, and as you see, where's the top? The RGB difference between each line here is 1, and as I say, your eyes, we've established that we can't see 16 million colors, so you shouldn't be able to see the difference in here, and that's why I said, so even using the most distinct RGB patterns, I could only generate 1,530. Let me quickly scroll down here. You can see this orange, yellow, chartreuse, green, spring green, aqua, what's this, azure, and you can see the colors and all the codes, violet, magenta, and back, as I said, back to rose and back to red. Okay. Yeah, so maybe what I wanted to say earlier, that if I've produced 1,530 distinct RGB codes, there are 16 million total RGB codes, which means it doesn't matter if you take this one to infinite, then this one's going to be infinitely more bigger. The rainbow, according to me, consists only of 0.0, it's actually 0.009% rounded to 1. Colors that we can see, that you will find in the rainbow, because as I say, they've got very distinct patterns, as I will show you later. Okay, so here did the same. I just stepped 8. So your eyes should be, although not maybe the, you should start seeing the lines between it. So just to show you, yes, all the colors just in a quicker step. Okay. So basically what I did, if you take these RGB codes here and you make a graph of it, it pretty much looks like this. And as I say, this initially didn't make a lot of sense to me. I used a bit of there's a program called Solver that my previous colleague, my previous work, Dave, has showed me. Thanks for that. I knew that to use Solver I had to use there were certain points, but before I get to that, so if you draw a graph of these colors, these RGB colors, this is what you get. And at some point it looked like a prism to me. And so I was wondering if you get, if all of them have the same angles. And I was wondering what angle and how, what method this guy used. Did he use a 60, 60, 60, or, I mean, this, I know it can't be true, but this almost looks like a picture of a prism, and I was wonder, it doesn't look like this. These two angles there are the same, but it's different from that. So this is a very strange pattern. I was expecting the rainbow to be a perfect sin graph, and as I said, but it took me very, very long to finally came to this. So what I'm showing you here now is the true graphs of a rainbow, and you can only, as I said, these triangle patterns here, and this took me very, very long to find out. And as I said, I had to work a bit with the AI. The AI was pretty useless, but it did give me good hints. And then using Solver, I started putting graphs, and initially, you know, initially the limit, you would think that graphs has a limit of 255, 255, 255, the height here. You would have expected that. So that's why I believe most people can't solve this puzzle, because they're thinking, what I'm basically saying, these higher rates than we anticipated. To tell you the truth, if you look at this height from 255 to 0, that height plus that height is the same. So let me just show you what I've done here. So let me go here. So basically, I looked on the internet. I say the wavelengths of the different colors. So I took red, green, and blue here, and that's what it is. So on my simulator, if I go change this, copy this. So basically, this is the number of waves. So I want to see one. I'm now mimicking that. So one wave, 1.2, 1.4. As you can see, and then obviously we want the starting angles the same. Let's make all of them 0. So you can see. So basically, yeah, I was trying to mimic. You can see red is a longer than green and shorter, just like we see here. And then the other thing is that the height of all these waves seems the same to me. So to truly mimic that, I must go 255, 255, 255. So this is how I sort of started, and I thought this will generate a rainbow. So if I click here on generate this graph, this is how it looks like, and as you can see, it looks very, very far from a rainbow. Okay. Let me just reset this again. So this is a simulator that you can play with. I thought, well, let me just show you the true rainbow. If you use these things, you get a rainbow. What was interesting, I was wondering why there's so much more red on this side. So yes, if I take these ones, I just want to show you again. I make this 255, 255, and 255. And I generate this one. As I say, you are losing these distinct things here. It doesn't look like that. Yeah. So, maybe got something of. Maybe I could just show you how does it look like when you have 2, 3, and 4 different waves. So I got 2 red waves, 3 like that, and let's generate it. You can see I can generate a lot, infinite number of more infinite number of patterns that does not produce a rainbow. A rainbow is very specific. Let's just see what I was trying to do here. Maybe just interesting colors. I'm going to copy these starting things in here. Oh yeah, whatever. Let's see how this one looks like. Oh yeah, I was trying to extend the red here, as I said earlier. So if you do this now, you would see the red is extended, but it doesn't look the same. And the reason, yes, this thing is a reverse. So this part here, this side, is what you see on that side. But as I say, although this is the same, our eyes can't probably see it. So I'm just saying the only wave that creates a pattern that looks like a rainbow, so, or these. So this is discovery I made. I just thought I'll share this with the world, that I've discovered the SIN graphs that will generate a rainbow. And how do I know? As I said, else my generation and this Baird guy produced is pretty much on spot. So yeah, I thought I would share this with you all, and that hopefully someone will find this of interest, or, you know, as I said, interesting discovery that I believe I've made is that our eyes can't see the full. Not only are we limited by a very, very small spectrum, it seems like we are also limited by the height. So when you go above 255, it obviously flatlines, and that is how these flat lines comes, how this, so basically this red goes like that, and down like that, and like that. But because our eyes can't distinguish, and we don't have an internet code higher than 225, because our eyes won't be able to see it, we see something higher the same as that. So I've now proven that our eyes can only see half of the height of the sine wave that produces a rainbow, and I thought that would be of interest. So yeah, so lastly, I'm just saying, if you found this of interest, then maybe you can go watch my other video about God said it would be light, and it's basically a theory that the sine waves has depth, and they actually are spiral, and like a prop of a boat, that sometimes it comes from the back, it comes to the front, here it goes fast, and you perceive this turn there, like it actually seems like the energy wave is slowing down, but it's actually going, it's actually running the same speed, it's just going away from you, and maybe it's coming towards you. But anyway, so yeah, I'll leave you to that. Thanks a lot. Have a nice day. Cheers.